Hello everyone, welcome to our channel Simplified Computer Science Concepts by Professor Rutuja. Today we will be learning global state in distributed systems. Now what is the global snapshot? So let us consider this real-time scenario wherein representatives from different countries are captured in one photograph, irrespective of time and irrespective of space. So all of them are at one place at the same time and a photograph is captured. Now imagine representatives sitting at their own country and sending messages. This is where the distributed snapshot comes in, because they are geographically located apart from each other and still they are having communication with each other. So here the challenge is to calculate global snapshot. What is a global snapshot? Global snapshot is nothing but a global state. Now global state is nothing but individual state of each process plus individual state of each communication channel. So let us consider there are these three processes that are there and some events that are occurring on the events. Now what we will do is we will take a snapshot of each site because they are geographically apart from each other. We will take snapshot of these individual process, then this individual process and this individual process. And let's say a process P1 is communicating with P2. So that means there is some communication channel present between them. So the state of these communication channels altogether will form a global state. That means the state of the processes and the state of the communication channels between the events. This together forms the global state. So here, if you just look into this picture as well, what is a global state? So if I want to find out a global state, it will be the local state of Pi, the local state of Pj, and these are the communication channels from Pi to Pj and from Pj to Pj to Pi. So the local states of these communication channels all together will form a global state. So the solution for this is synchronization. However, synchronization leads to errors. Why? Because as we have seen earlier in the earlier classes, skew is one of the major drawback. So here, if we consider a bank informing that due to clock skew, the bank balance, which was earlier 1 lakh rupees, is now nil. It is a very risky case over here. So if the synchronization is not there, then it will lead to huge catastrophic errors. So instead of synchronization, we go and opt for causality. Now causality is best solution to capture a global snapshot because here we are just ordering the events with the relationship of happens before relationship. Now any minor change in the system will change the global state of the system. So even if a certain transaction is changed from, let's say, Pi to Pj, even if some small transaction is made at its local site, the entire global state changes. Now there is a concept called cut. This cut is nothing but a set of events or a time frontier at each process or a time boundary at each process. So at a particular time, a cut is taken for all the events. Now this event, if the event that is to the left of the cut, it is considered as in the cut, and event that is to the right of the cut is considered as out of the cut. The two types of cut, consistent cut and inconsistent cut. So consistent cut, a cut that obeys causality. So let us consider an example. Let us consider two events A and B. If A is in the cut and B has happened before A, then B is also in the cut. Now just look at this example. So this is where the events are taking place, and all of them are ordered with the help of logical Lamport logical clock. Now this is the cut that has been taken. Now consider this cut. The events that are to the left are inside the cut. The events to the right are outside the cut. Now let us consider this B event. It is inside the cut, so it is a sending event. So sending event and inside the cut, it is fine. And event H is a sending event inside the cut, not a problem. It can still be a consistent cut. And E is the receiving event, which is outside the cut. So no problem. So that is why it is the consistent cut. Now let us consider this cut, which is inconsistent cut. Now why it is called as an inconsistent cut? Because see, to the left are inside the cut. So to the left is what? Receiving event. So receiving event, but then its sending event is outside the cut, because the events which are to the right are outside the cut. So if sending is not inside the cut, how the particular event will be received? So this is inconsistent. Unless and until a message has been sent, it cannot be received. So the sending event should also be inside the cut, then only this cut will be consistent. Otherwise this is marked as inconsistent. Again, if you see this particular event here, receiving event is inside the cut, but E, that is the sending event, is outside the cut. Here again it is an inconsistent cut, because the receiving is inside the cut, and for receiving the message should be sent. The sent message is outside the cut. So this is inconsistent cut. So I hope you have understood this concept of consistent cut and inconsistent cut. Thank you for watching the video. Please like, share and subscribe to the channel Simplified Computer Science Concepts by Professor Rutuja. Thank you for watching the video, and if you have any doubts, you can write it into the comment box. Thank you.